Hello students, now we are going to start the 6th unit of your crash course, which is thermodynamics. It is 6th unit. Of your crash course program. And it is thermodynamics. Thermodynamics means we are getting energy from thermal energy. Thermodynamics. So there are 3 laws of thermodynamics. Law 1 is very simple. If we have 3 systems and one system is in thermal equilibrium with 2 other systems, then the 2 other systems, they should be in thermal equilibrium with each other. It is 0th law of thermodynamics. It means if one system individually in thermal equilibrium with 2 another systems, then that 2 systems should also be in thermal equilibrium with each other. What is first law of thermodynamics? Only this law is mathematical. When you are supplying heat energy to a system, it will divide into 2 parts. One part will increase the internal energy and second part will do work. Now what about sign convention? You can learn in this way. If we are moving from left to right, all things are positive. We will tell you the sign of du differently. Separately, I will tell you that this. It is about dq and dw. Left to right means if system is absorbing heat energy, dq should be taken positive. If system is doing work, work should be positive. System absorbing heat and doing work, both are positive. If we are doing work and it produces heat, means system is liberating heat, both should be negative. Du sign convention is simple. If internal energy is increasing, sign of du should be positive. If internal energy is decreasing, sign should be negative. Clear to you? It is very simple. Left to right, dq, dw both are positive. Means system is absorbing heat energy and doing work, both are positive. If we are doing work on system and that work is producing heat and that heat is liberated from the system, both should be negative. If internal energy is increasing, du should be positive. If it is decreasing, du should be negative. Definitely you are going to get one problem in your NEET exam from this statement. So be careful about this. Now second law of thermodynamics, it has 2 parts. 2 statements are there in second law of thermodynamics. First statement was given by Kelvin Planck, related to heat engine. Second was given by Clausius, related to refrigerator. What is Kelvin and Planck's statement? You cannot convert whole energy which you take from the hot reservoir into useful work. It was the statement of Kelvin and Planck. What is second statement? It is given by Clausius. You cannot supply heat energy from low temperature to high temperature without external energy or without help of external energy. This part was given by Clausius related to refrigerator, because in refrigerator you are doing same. You are taking heat from low temperature reservoir and sending it to high temperature reservoir with the help of external energy, which is electrical energy. So there were three laws related to thermodynamics: zeroth law, first law and second law. Which one is mathematical? Only first law of thermodynamics is mathematical. Now, there are some process when you are doing some work, you are supplying heat energy to some system, it will expand, or if you are compressing a system, it will give you heat. So there are four processes which you should learn for your NEET competitive exam. One is isothermal. One is isothermal process. What is isothermal process? In which during whole process temperature is constant. We know from gas equation PV is equals to mu RT. If temperature is constant, R is universal gas constant, mu is constant, number of moles, it means in this case PV should be constant. It is known as Boyle's law. Means at this time your system will follow Boyle's law. After isothermal process, second one is isochoric process. What is isochoric process? In this, volume is constant. In this process, volume should be constant. Volume is constant, mu and R are constant, means P is directly proportional to T. Pressure law. In isobaric process, pressure is constant. If pressure is constant, V is proportional to T. Charles law. So one more thing is there. If process is isochoric, and we know that pressure into change in volume is equals to work done. But if pressure is constant, it means in this process work done should be 0. It means if process is isochoric and you are supplying heat energy to system, but system will not do work. So what will happen with your supplied energy? It will use in change in internal energy. Means it will only increase the internal energy of system. Next one is adiabatic process. What do you mean by adiabatic process? In adiabatic process, heat is constant. Means neither system is absorbing heat from atmosphere nor it is liberating heat energy to atmosphere. So all heat content is inside the system only. In this, gas follows this law, which is known as Poisson's law. PV raised to the power gamma is equals to constant. So now, and one more thing, in isothermal process, since temperature is constant, so in this type of process, change in internal energy is zero, because internal energy is always a function of temperature. If you increase the temperature, only then its internal energy will increase. Now, we will try to calculate work done in isothermal process. We know that work done is always pressure into change in volume. So, we apply a pressure P and change the volume by a small amount dV. So, small amount of work done is P into dV. If you integrate this, you will get full work, means integration of P dV. Suppose you want to change the volume from V1 to V2, but we are going to integrate with respect to V, but V is not there. We know that at this time gas is following Boyle's law and it is PV is equals to constant. So remove this P with the help of this law. So work done will become integration from V1 to V2. P means K by V dV. K is constant, take outside the bracket, and integration of 1 upon V is log V. So now we can write, and we know that what is PV? PV is equals to an actual mu RT. Since T is constant, therefore PV was constant. So you can write in place of K this mu RT also. V2 minus V1 means log V2 by V1. So it was work done in isothermal process. If you want to calculate work done in adiabatic process, suppose we applied a pressure P to change in volume by dV. So work done should be integration of this. We will get first small amount of work P into dV. By integrating this, we get full work. Suppose you want to change the volume from V1 to V2. Again, V is not there, but we know that at this time, gas is following Poisson's law. PV raised to the power gamma is equals to constant. So we are putting the value of P, K upon V raised to the power gamma. Take K outside. So what we are getting? V raised to the power minus gamma. Increase the power by 1 and divide by the increased power. So K upon 1 minus gamma. What we are getting? V raised to the power minus gamma plus 1. Now we have to solve limits V1 to V2. So what we are getting? K upon 1 minus gamma. V2 raised to the power 1 minus gamma minus P1 raised to the power 1 minus gamma. If initial temperature was T1 and final temperature was T2, we know that P1 V1 is equals to mu RT. What we are doing? We are putting PV raised to the power gamma is equals to K. If initial pressure was P1, volume was V1, temperature was T1. Final pressure was P2, volume was V2, temperature was T2. So it means P1 V1 raised to the power gamma is equals to P2 V2 raised to the power gamma. We write K for this. Now we are taking K inside, and in place of K, where K is multiplying with V2, I am writing P2 V2 raised to the power gamma. Where we are going to multiply K by V1, we will write K P1 V1 raised to the power gamma. So by taking inside, what we are getting, here I will get P2 V2. Next I will get P1 V1 divided by 1 minus gamma. But what is PV? PV is equals to mu RT. So we are getting work done is equals to, take mu R common, mu R upon 1 minus gamma. In place of P2 V2, we write mu R T2. So inside we have T2 minus T1. So we can write it mu R upon gamma minus 1, take minus sign common, into T1 minus T2. So mu R upon gamma minus 1 into T1 minus T2, it was work done in adiabatic process. So getting my point? So in this way, we are able to calculate work done in isothermal process and work done in adiabatic process. Now we are switching to heat engine. What is heat engine? It is made by, ideal heat engine is made by Carnot. So you can say we are going to discuss Carnot heat engine, or first we are going to discuss Carnot cycle. Both we will discuss same. There are three essential parts. One is source of infinite thermal capacity with temperature T1 Kelvin. Second thing is working substance, and for working substance we are using ideal gas. It is ideal gas. And this part is conducting and plate form is non-conducting. It is plate form. And third part, it is a low temperature reservoir known as sink of infinite thermal capacity. It was source of infinite thermal conductivity. What do you mean by infinite thermal conductivity? We know that if we are taking some heat energy out from some object, temperature will down. If you will give heat energy to some object, its temperature will rise. But see, same thing is in water. If we are taking out some liquid from a container, liquid level will down. If we put some additional liquid in a container, liquid level will rise. But what will happen? If you add 1 bucket of water in ocean, water level will not rise. Why? Its capacity to contain water is infinite. If you are adding 1 bucket water to ocean or you are taking out 1 bucket of water, water level will not suffer. Same thing is happening here. Source and sink both are of infinite thermal capacity. If you are taking out some heat or if you are giving some heat, temperature will not change. It was the meaning of infinite thermal capacity. So what we are doing, in first step, we will put our working substance, and as a working substance, we are using ideal gas. We are using ideal gas. When we are putting this on this source, the working substance will get heat from outside. Gas will expand. Means gas is doing work. But what energy gas needed to do work, it is getting from outside. So its temperature will remain constant. Initial, the thermal coordinates of gas were P1, V1 and T1. So no change in temperature. What energy gas needed, it will get from outside, means from this source. I am making graph for this process. So gas was at this point. Volume is increasing. It is pressure and it is volume. What is happening? Process is isothermal. Gas will follow Boyle's law. Means pressure into volume. This product should be constant. Gas is expanding, means volume is increasing. But product should be constant, so pressure will decrease. So from this, height will lose. Graph will lose height. But volume is increasing. So we are moving towards positive axis of y. This, we came at B. What happened at B? Pressure was changed at A. Pressure was P1, volume was V1, temperature was D1. This is isothermal process. State changed. PV2, now gas is at this point. Pressure changed to P2, volume to V2, but temperature was constant. Now I put the working substance on plate form. On first step, it was here. On second step, I am keeping it here. Due to inertia, again gas is expanding. Piston is moving in upward direction. But now external supply you cut off. Means now gas is not getting energy from outside. It means now it is using its own energy. So temperature will decrease. But since pressure is increasing, volume is increasing, pressure should decrease. Now it is not at constant temperature. So it will follow Boyle's law. PV raised to the power gamma is equals to constant. If this term is increasing, it should decrease. So we will go from B to C. Pressure is P3. Volume is V3. But now temperature is changing. So suppose we will do this up to the temperature, we will get T2. After that, we will put this working substance on this sink. Now we will start compress the gas. Now we are compressing the gas, means volume is decreasing. In this process, molecules will collide with each other and heat will produce. Temperature of gas will rise. But if two objects are nearby and one temperature is increasing, heat will flow from high temperature to low temperature. So whole heat will transfer to sink. means again now temperature is constant. Since volume is decreasing means pressure is increasing. So graph will get height, and volume is decreasing means we will move in this way. Temperature is not changing, so this process is again isothermal. And this process was adiabatic. So we came at this point D. Now pressure is P4, volume is V4, and temperature is constant T2. Now we will put this working substance again on platform 4th. We start compressing the gas. Now since gas heat cannot go outside because it is non-conducting platform, so it will increase the temperature of gas. So again temperature is increasing. Since pressure is increasing, volume should decrease. We will do up to the point we will get temperature T1. Since gas is ideal, if again pressure is after increasing P1, temperature is T1, volume should be V1. So it is the complete one cycle. Now we are again at A. Your working substance is again ready for second cycle. So what your working substance did? When it was on first step on the source, it was taking heat from source. And at this step, it was giving heat to sink. And difference it used in doing work. So what should be the efficiency of this? It take an amount of heat Q1. Efficiency means output upon input. Output was Q1 minus Q2 and input was Q1. So efficiency was 1 minus Q2 by Q1. We can calculate Q1. What work gas was doing at that time? It was getting energy from outside. Since it was isothermal process, so we can say RT, we just calculated work done in isothermal process, mu RT log V2 upon V1, final volume upon initial volume. So we can say RT mu R T1, temperature was constant in T1, log final volume was V2 divided by V1. It was Q1. What was Q2? When we were from C to D, at that time work done was equal to Q2, means mu R T2 log. What was final temperature? In this process, it was V4 by V3. V4 by V3. Next, from A to B, gas was following Boyle's law. It means P1 V1 is equals to P2 V2. From B to C, it was adiabatic process. P2 V2 raised to the power gamma is equals to P3 V3 raised to the power gamma. Again from C to D, it was isothermal process. So P3 V3 was P4 V4. From B to D to A, again it was adiabatic. So it was P4 V4 raised to the power gamma is equals to P1 V1 raised to the power gamma. Multiply these four relations. On left hand side, you will get P1, P2, P3, P4. Next, V1, V3, V2, V4 raised to the power gamma. On the right hand side, you will get P1, P2, P3, P4. V2, V4 into V1, V3 raised to the power gamma. Cancel this P1, P2, P3, P4. You will get V1, V3. 1 V1, V3 will cancel out, raised to the power gamma minus 1 is equals to V2, V4 raised to the power gamma minus 1. So what we are getting, V1, V3 is equals to V2 into V4 means V2 upon V1 is equals to V3 upon V4. Now we are going to our sign convention. I told you in previous slide what should be the sign of dq and dw. A system is absorbing heat, dq should be positive. A system is liberating heat, dq should be negative. So in first process, system was absorbing heat, so q1 was positive. In this process, system was liberating heat to sink, so q2 should be negative. So q2 should be negative. So we applied that sign convention. Now see, what is q2 upon q1? If we divide q2 by q1, mu RT is cancelled out. What we are saying? Minus. You can use this minus sign in log's power. So you can write it mu RT2. We are taking minus sign in power because log m raised to the power n is n log m. So if we are going to take power here, we will get q2 is equals to mu RT2 log V3 upon V4, V3 upon V4. So what we will get? Minus we use there. So no need to write this minus sign. Mu r will be cancel out. T2 upon T1 into log. In Q2 it was log V3 upon V4. And in Q1 it was log V2 upon V1. But from this we know that log V2 upon V, since V2 upon V1 and V3 upon V4 are equal, so they will cancel out. So what we are getting? Q2 upon Q1 is equals to T2 upon T1. What we are getting? Q2 upon Q1 is equals to T2 upon T1. So in terms of this, now you can write efficiency of heat engine 1 minus T2 by T1. Since T2 is always less than T1, so it means the efficiency of this Carnot heat engine, which is an ideal heat engine because we were using ideal gas. Again, its efficiency is not 100%. It means even you use ideal condition, take a source of infinite thermal capacity, take a sink of infinite thermal conductivity, as working substance use ideal gas, you will not get 100% efficiency. It is less than 1, it means in percent, it is less than 100%. So any heat engine in practice which is working with temperature T1 and T2 cannot get efficiency greater than the efficiency of Carnot heat engine, because Carnot heat engine is an ideal heat engine. That's why Kelvin and Planck stated in its second law of thermodynamics, it is not possible to convert 100% energy, heat energy into useful work which you got from source. Getting my point? So you can get one problem on this concept in competitive exams. On heat engine, nearly every year we are getting one problem. What is refrigerator just doing in opposite manner? What we are doing? We are taking Q2 heat from sink. In this, we were using two reservoirs, one hot temperature and one was at cold temperature. What we are doing in a refrigerator? In refrigerator, we are taking Q2 heat from T2 temperature, low temperature reservoir, and doing some work on this and supplying this to high temperature reservoir. Means W plus Q2 is equals to Q1. Means Q1 minus Q2 same, it is W. But in this, we are using a term coefficient of performance. It is what energy? What is coefficient of performance? What energy you can take out from low temperature reservoir and what minimum work you have to do done on this to supply high temperature reservoir. So it is coefficient of performance used in means Q2 upon Q1 minus Q2. Divide numerator and denominator by Q2. So you can write beta. Q2 upon Q1 means T2 by T1. Dividing by Q1, it is 1 minus T2 by T1. So what we can write this? T2 upon T1 minus T2. So it was coefficient of performance. Means with heat engine, which term is associated? Efficiency, 1 minus T2 upon T1. And term associated with refrigerator is coefficient of performance. What it is? It is T2 upon T1 minus T2 or Q2 upon W. So remember always. So now we will start problems based on these thermodynamics, heat engine, from all three laws, refrigerator, what they are asking or they can ask in your competitive exam. We will discuss in next slides. Thank you.